Far beyond the warm embrace of the sun, where light fades into the chill of space, drifts a mysterious bluish world, Uranus, the seventh planet from the sun. To the naked eye, it remained hidden for centuries, until 1781, when astronomer William Herschel first spotted it through his telescope, forever expanding our map of the solar system. But Uranus did not begin its story in the 18th century. Its origins stretch back billions of years, long before human civilizations emerged. Classified not just as a gas giant, but more accurately as an ice giant, Uranus is composed primarily of water, ammonia, and methane ices. These ingredients hold secrets from the solar system's earliest days. Studying the age and formation of Uranus is like turning the pages of a cosmic diary. Each discovery brings us closer to understanding how giant planets formed, migrated, and shaped the destiny of the worlds around them. Through Uranus, we glimpse the frozen heart of our planetary past. Roughly 4.5 billion years ago, in the shadowy outskirts of a young and turbulent solar system, Uranus began to take shape. It was a time of chaos. Clouds of gas and dust swirled around the newborn sun, collapsing under gravity, spinning, colliding, and merging in a cosmic dance that would birth the planets. This process, known as the nebular hypothesis, laid the foundation for everything we now know. The sun at the center, and around it, a disk of cooling material slowly crystallizing into worlds. Far from the warmth that nurtured the rocky inner planets, Uranus formed in a much colder realm. Out here, the temperatures plummeted, cold enough for volatile compounds like water, ammonia, and methane to freeze solid. These ices gathered together, forming a dense core, the heart of Uranus. With time, this icy core grew large enough to attract surrounding gas and frozen materials through its growing gravitational pull. Unlike Jupiter or Saturn, Uranus never acquired a massive gaseous envelope. Instead, it developed a thick, icy atmosphere, less immense but uniquely alien. In this frigid cradle of the solar system, Uranus was born, a pale blue wanderer made not of fire and fury, but of stillness, ice, and time. How do you measure the age of a planet, a world that formed long before the first human gaze ever turned skyward? Uranus doesn't carry a birth certificate, yet scientists have found clever ways to trace its origin using the silent witnesses of the early solar system. 1. Radioactive clocks and meteorites. Long before Uranus existed in its final form, fragments of cosmic rock, meteorites, were drifting through space. These ancient relics contain radioactive isotopes, such as uranium and lead, that decay at predictable rates. By analyzing these isotopes, scientists can read the natural clocks inside the rock. The result? A consistent age of about 4.56 billion years, a timestamp shared by the entire solar system, including Uranus. 2. Solar system dynamics and simulations. Beyond the physical evidence lies the power of simulation. Scientists build computer models of the early solar system, watching as digital dust and gas evolve into planets. These simulations consistently show that Uranus formed alongside Jupiter, Saturn, and Neptune in the early chaos, migrating outward as the solar system took its current shape. The patterns match what we observe today. 3. Tracing the heat within. Even in the silence of space, a planet can whisper its past through heat. Uranus, though cold on the outside, still holds residual warmth from its formation. By modeling how Uranus has cooled over billions of years, scientists can estimate how long ago it began radiating that internal heat. The findings point once again to an ancient origin. Together, these methods form a mosaic of evidence, each piece helping us peer back through the eons. Through rock, motion, and heat, we uncover the deep time story of Uranus, frozen in its elegant orbit since the birth of the sun. Knowing the age of Uranus is more than a matter of dates on a cosmic timeline. Hidden within that number, 4.56 billion years, are profound scientific insights that stretch across space, time, and even to worlds beyond our own. 1. A living archive of the solar system's history. Uranus is not just a planet, It is a survivor from a turbulent past. By tracing its age, scientists can align its story with key events in the early solar system: planetary migrations, massive collisions, and the swirling redistribution of gas and dust. Uranus becomes a living archive, holding clues to the chaos that shaped the planets we know today. Unlocking the mysteries of ice giants. Uranus and its distant cousin Neptune represent a rare and poorly understood class, the ice giants. Their cold compositions, unique internal structures, and, especially in Uranus's case, extreme axial tilt, nearly 98 degrees, continue to puzzle scientists. Understanding when and how Uranus formed provides a key to decoding its strange behavior, both inside and out. Looking beyond, comparing with distant worlds. The more we learn about Uranus, the better equipped we are to study exoplanets, planets beyond our solar system. Many of the ice giant-like exoplanets discovered so far share similar masses and orbits. By comparing Uranus to these distant worlds, astronomers can ask a critical question: is our solar system unique, or is it one chapter in a much larger galactic pattern? 4. Charting the course for future exploration. Since Voyager 2's flyby in 1986, Uranus has been waiting, quiet, distant, and largely unexplored. But its age and geological history are essential for shaping the next generation of space missions. Understanding how Uranus evolved helps scientists choose the right instruments, targets, and questions for the spacecraft of tomorrow. In the cold twilight of the outer solar system, Uranus orbits in silence. But the story of its age echoes loudly across science, guiding our search for origins, on Earth, among the stars, and deep into the future. Though it spins in silence at the far edge of our solar system, Uranus carries the echoes of an ancient universe. Its age, etched in isotopes, orbital paths, and lingering warmth, reveals a world born alongside the Sun itself, some 4.5 billion years ago. Through the lenses of science, radioactive dating, planetary models, and thermal simulations, researchers have pieced together the hidden history of this ice giant. And in doing so, they have done more than explain Uranus. They've unlocked a chapter of the solar system's origin story. Each discovery about Uranus not only deepens our understanding of its icy layers and tilted spin, but also helps us answer a greater question: how did planetary systems, and ultimately life itself, begin in the cosmos? In the cold, distant blue of Uranus, we find not isolation, but connection. A reminder that even the quietest planet holds the loudest truths about where we come from and where we might be headed.